Welcome to Sec 209, least privilege, moving beyond default service accounts. Right? I am Ian Lewis. I am a developer advocate at Google. I focus on security and particularly on cloud-native security. But today we're going to be talking about everybody's favorite topic, IAM. So the agenda for today is going to be starting with a intro into IAM and service accounts, just kind of talking about what IAM is and just level setting. Then we'll talk about default service accounts and what they are. And then we'll talk about the principle of least privilege and why it's important and what it is. Next, we'll talk about some practical attacks, things that happen when you don't adhere to least privilege and use default service accounts, what sort of issues that can cause. Next, we'll talk about least privilege and applying least privilege and using custom service accounts and roles. And then finally, we'll talk about automating least privilege, so making sure that you're applying least privilege on an ongoing basis and all of your projects in your organization are secure. All right, and then finally, we'll do a wrap-up at the end and just summarize the things that we've learned. So before we try to jump into Cloud IAM and service accounts and kind of do a little bit of level setting and an intro, how many of you, when you start up your Cloud Run services and things like that, you just use the default service accounts as they are, right? Just go ahead and raise your hand if you do that. All right, a lot of you are liars. All right, no judgment though. We all know that default service accounts are just super easy to use. But first, let's kind of dive in and talk about a little bit about what IAM is and what it does and how to think about it. So IAM is identity and access management. But effectively what it is a platform for defining how users and identities can do things on the platform, how to give them access to things. So effectively what you're doing is you're defining who can do what with a particular resource, right? So effectively it's an object, verb, subject kind of a scenario. So in the case of in identity and access management, when you're talking about the who and the what and the which, in this case, well, we're talking about things like users and groups and service accounts. When we're talking about things like identity, when we're talking about what you can do, these are defined by roles and permissions within IAM, and we'll talk a little bit about each of these as we go along. And then finally, the what or the which thing that you get access to are resources. And this can be defined at various different levels within your projects and within your organizations. So the idea is that Google Cloud is a platform, right? And it's a shared security model. So what that means is that Google does its best to make sure that Google Cloud itself is secure, and Google Cloud itself won't be compromised. But also, it's very important to make sure that applications and your projects are not compromised as well, and that includes making sure that your IAM setup and your IAM roles and policies are set up in a way to make your projects themselves most secure. So it's a shared model. Both the users of Google Cloud and Google Cloud itself have responsibility for the security of your applications. All right, so let's dive a little bit deeper into each of those areas. First, we'll talk about accounts and what those are. So accounts or identities within IAM can be either user accounts, and so these are effectively a user, so an actual person, typically. So this means basically a workspace account or a Gmail account, something like that. You can also An identity with IAM can also be a group, so this can just be a group of users or in this case, service accounts, but basically just a group of other identities that can be thought of itself as an identity. And then finally, service accounts, which are an account that's made for applications and services themselves. Right, so we'll dive a little bit deeper into what service accounts are. Service accounts are basically just like any other kind of account. They're identified by an email address. So in this case, we have like MySA, but this is basically a name, a user-defined name. And then it takes the form of that user-defined name at project.iam.gserviceaccount.com. So it's kind of a long email address, but it's effectively the same sort of email address that a normal Gmail account might have. So you can kind of think of it that way. And when you look in your IAM console and within the API and stuff, if you see an account email like this, you'll know right away that it's a service account. These can be easily attached to service accounts or to services within Google Cloud. So when you deploy apps to Cloud Run or to a Google Cloud Build trigger, things like that, you can attach these service accounts to them and run those applications as that service account. So it's basically, the service itself is a user. That's how you kind of think about it. And you can authenticate as these service accounts using service account keys when you're doing it outside of GCP or outside of Google Cloud. Next, roles and permissions take a few different types of forms. So like there's, I think if you've used IAM before, you might have seen these, but these are broken down into basic roles, and these are the owner, editor, and viewer roles. And these are very, very powerful roles within your project that give you many, many permissions. So the owner role here will have 8,207 permissions, for example, right? So this effectively can do anything within your project. The editor has a very similar number of permissions, and then the viewer has all of the permissions to view all of the resources in your project. Then there's a number of predefined roles, and these are typically roles that are defined based on individual services within Google Cloud. So for example, Google Cloud Storage, you might have the Cloud Storage object owner or bucket owner type of permissions roles. And these have a much smaller number of permissions, but these are typically based on a particular service or a particular product within Google Cloud. So either data store or compute engine. Within each of these, there may be a number of different types of roles depending on the types of resources within that product. And then finally, we have resources themselves. So resources are things like VMs or networks or any type of object within Google Cloud. And these resources then form a hierarchy with projects and folders and organizations. So when you have a workspace organization, that's kind of the top level resource hierarchy. And then within an organization, you can have folders, and these folders can have subfolders, et cetera, which form a hierarchy. And then inside each of those, there's a project, and then inside of each of those, there's resources, right? So this forms kind of a hierarchy, right? And then IAM policies can be applied at each level of the hierarchy. And then, so for example, you can apply IAM policies at the organization level, at the folder level, and at the project level. And then when you define them at these levels, they then are inherited into their children within the resource hierarchy, right? So if you, in this case, define a policy at department A, that then applies to team A and team B, which then gets applied to the projects within those folders. Great. So we've kind of covered IAM itself. Let's kind of talk about what a default service account is. So default service accounts are a special type of service account. These are service accounts that are created with your project kind of automatically. And they are a way of defining a default set of permissions or set of default service account that when you deploy an application, it gets applied to that particular, say, Cloud Run service or Cloud Build trigger automatically. And it typically has a very broad set of permissions associated with it. So in the normal case, you have editor assigned to, say, the cloud service or the compute engine service account. And this has very broad access to your project, and it's great for getting started and for ease of use, but it can be easily overlooked when you're deploying services because it's applied by default. And when you deploy these services, like, they just kind of work, right? You have all the permissions you need, but then you have a lot of extra permissions which you don't necessarily need. So your applications will work and everything is fine, but you don't really notice that you're actually including a lot of permissions that you don't need, and so these are often overlooked. These are also user managed, so they're created automatically within your project, but they're ultimately on the user to manage them. So these are not managed by Google Cloud itself. So examples of the default service accounts are the default compute engine service account. This is one that is pretty well known. You should see these in most projects. There's also a Cloud Build service account, but this is actually going away at the end of the month. I believe it's April 29th. This is going away, and Cloud Build will start using the compute engine service account as its default. And then we also have the App Engine service account, which is the default service account for App Engine. So there's very few default service accounts, but these are used widely across Google Cloud in various services. So Cloud Build, Cloud Run, Cloud Functions, Compute Engine, etc. Awesome. There's one more type of service account that I want to touch on. But we're not going to dive too deeply into this one. But these are Google Managed Service Accounts. These are service accounts that are similar to the default service accounts, and they're automatically created. But these have a different purpose, right? So, for example, when you have deployed to Cloud Functions second generation, this will create a Google Managed Service Account for Cloud Functions, which allows Cloud Functions to deploy to as a Cloud Run service. So what they are doing is effectively giving Google itself, or Google services themselves, permissions or access to your project to do things within your project. So these are completely automatic and Google managed, so you don't have to worry about managing themselves, but they will show up in your IAM console, so it's good to know about them. All right, so we've kind of level-setted on IAM and service accounts and default service accounts. Now let's talk about why default service accounts might not be the best thing to use when you're running, say, a production service or in real life, right? So what I want to do is talk about the principle of least privilege. So this best illustrates why it's maybe not the best way of, or the best thing to do to use default service accounts, is that least privilege as a concept is that each system should only have the permissions that it needs to do its job. And why that's important is that each application, like if it's, for example, compromised, then the credentials and permissions for that particular service can then be used to do malicious things within a project, right? And what we want to do is minimize the number of things that can happen if a service account is compromised within a project, right? So what this does is it limits the quote-unquote blast radius, or the damage that can happen within a project if that service account is compromised, right? So like if you only give it the permissions that are needed to do its job, then none of the extra permissions can be used to, for example, laterally move to another project, or to gain access to another thing that can lead to another thing, which can lead to your end user data being leaked, or your project getting deleted, or something else, right? So what we want to do is just minimize that damage when that happens. This makes applications like easier to deploy while also meeting security goals, right? When you think about this, you're like, okay, I know exactly how many permissions I should attach to this particular project because I know exactly what this particular application needs, and so I'll give it only exactly what it needs in order to run. This also can help improve productivity because what you can do is when you run an application, you can monitor what exactly it does, right? If you don't know exactly what the application code is doing necessarily, if you're, say, an SRE, you're not actually the developer of the app, you can still run it and kind of monitor it and see what sort of things it uses, and then use that to define what permissions and what roles you can attach to that particular service account. All right, so let's think about what might happen if we don't really, or we don't follow the principle of least privilege, right? What can happen if we are not, if we have like extra permissions on something that we are running in a project? I mentioned lateral movement, but like one way, and this is one way that attackers gain access, is by exploiting one vulnerability in order to expand their access to another area, which can then lead to another area, and they can expand out through privilege escalation until they get to something that is really valuable. And there's a really good blog post on this within Google, on the Google Cloud blog, about how to prevent lateral movement techniques in Google Cloud. So I recommend you look at this. This is also talking about IAM and least privilege. And I'll bring up a couple of examples that are mentioned in the blog post. One of those is, for example, snapshot creation, right? These are a few different examples that are that can be easily overlooked when defining IAM roles. So for example, snapshot creation is creating a snapshot or a backup of a disk. So for example, you might have a VM that's created from a disk. And IAM you might have an IAM role that doesn't necessarily have access to the VM itself, but maybe it has access to create snapshots. And so if that particular service account is compromised, you might, that attacker might be able to create a snapshot of the disk and then attach that to a VM in a project that they control, and then be able to read all of the data that's on the disk, for example. Another is using the metadata server, things like reading SSH keys or having access to the serial console for VMs. These are also areas that are typically overlooked and can be used for lateral movement into other areas of a project. So these are some examples that are like easily overlooked, but it doesn't necessarily need to be quite that complicated when you're talking about an attack. Like for example, you might have your IAM policy set at the wrong level. For example, let's say we have our cloud storage object owner permission or set at the project level. That would give access to all of the buckets within a project, even though the application only needs access to one particular bucket or two different buckets. So this can lead to a leak if that service account is compromised, because that could then be used to read from a different bucket that might contain data backups, for example. So let's take a look at an example of what that might look like. So here we have a service account which has storage object user permissions, right? And our application is saving some static data to a cloud storage bucket, right? So we have an assets bucket here, and our application allows users to upload files, and we put them into this bucket. That's good. But what you'll also notice is there's another bucket in there which has our MySQL backups, right? And so if this service account happens to be compromised from the application, then an attacker could authenticate with that service account and then download the backup files from that backup in the separate bucket. So here we're listing the bucket. We can see that we actually have our backup SQL file in the bucket, and we can just go ahead and download that because we have access to all the buckets within the project. Right? So when we're thinking about least privilege, we have to think about things like where the IAM policies are set, at which level are they set? Are they set at the appropriate level? As well as what permissions are set. So in this case, we had access to more buckets than we wanted to. All right, so how do we solve this type of problem? So setting it at the right level is one way, but another way is to set to create custom service accounts and roles. So this is setting the right types of permissions. So for example, with custom service accounts, we don't want to use the service accounts that are default and created for us. We'll actually create our own service accounts and give them their own name, right? And we do this, like, for example, on a per service level, and doing this like for one specific purpose. So we'll create a custom service account, and these work exactly the same way as the built-in default service accounts that are created for us. Like they have a name, like just like the default service accounts, but they're a custom name for us. And then we can attach these to our services when we deploy them. So normally when we deploy an app, by default it'll get the default service account, but we can actually specify our own custom service account that we've created that has its own custom set of roles. And then on top of that, we can create custom roles. And these are roles that have a custom set of permissions. So depending on what sort of roles we have within our projects, we might want to create custom roles that have a exactly the permissions that we need. So not just the built-in and predefined ones, we can use our own custom ones that are even leaner and are very much closer to the exact permissions that we need for the application. So when we do this, we can set like a custom set of permissions and then manage these like exactly like and use these exactly like we would a predefined role. All right, so why do we really want to go through all of this trouble? So one of the reasons is that this allows for a separation of concerns, right? We're not using the same default service account for our compute engine and cloud build and cloud functions. We have service accounts defined for each of these different functions and each different purpose, right? And we might have even like service accounts defined for each individual cloud run service within our project even. So this allows us to create separation of concerns and define a set of roles and permissions that are custom for each individual purpose. Right? The roles themselves are also created for each individually for their own specific needs, right? So we might have, and we can create these at a pretty granular level. So you can think of these like not just, for example, if we have an SRE role within our organization, we wouldn't necessarily give them all of the permissions to that an SRE needs and create an SRE role. We might create a set of smaller roles for our custom role. So for example, we might have a backups management role, which we use to manage backups. And then we have a separate role to use to manage services, for example. So we can then give the minimal amount of permissions that we need to accomplish the task and use this to accomplish the principle of least privilege. Okay. So now that we've done that, how do we automate least privilege within our projects? Automating least privilege is what we want to accomplish when we're automating least privilege is we want to make sure that we are not just setting up least privilege one time and making sure that we're creating custom roles and service accounts once. We want to make sure that we're doing that on an ongoing basis. So for example, within an organization, you might have many, many people within your organization, and many people have access to change the IAM roles, and you might have many projects and many different folders, and you need to have a way of making sure that you're applying least privilege to all of the projects and all of the folders within your organization. And this can be pretty difficult to manage. This is something that you don't want to have to go individually into each individual project and look at the IAM roles and the service accounts within each of those projects in order to make sure that you're applying least privilege. Even if you look at your policies in each of the projects, it can be hard to know whether you're actually applying least privilege or not. And so one of the ways that we can do this is by using organization policies. And what we can achieve here is setting a set of policies that are applied to an entire organization, either an organization's folder, or an actual project itself. So it's not just for organizations, we can set these at an organization, folder, or project level. And what these do is help restrict the types of resources that we can create within the project. And this includes things like service accounts and IAM policy, right? So there's a number of things that we can do to limit what types of service accounts and what sorts of roles we can create within our organization. So what this is doing is helping us create a kind of baseline or a minimum set of security within the organization or within a folder or within a project so that sort of baseline security is preserved over time, right? So you can't just create a new service and set up your project, apply least privilege, and then later create a new service and just use the default service account. We want to make sure that all future services are also using the principle of least privilege. So some example policy constraints that you can set on organization policies are the automatic IAM grants for default service accounts. This is a really important one, particularly for this presentation, because this will disable the automatic grants on default service accounts. So by default, a default service account will get the editor role, which has broad access to your project. And what this particular policy constraint does is it removes the role grant to the default service account. So the default service account will actually still be there, right, for your projects, but it won't be granted any permissions. And so this forces your users to think about which permissions are actually and which roles are actually needed for services when they deploy them, right? So if they deploy with the default service account, they'll actually have no permissions available for that service account. And so if they need some permissions, their application may fail, but this actually just gets them to think about creating a custom service account and think about what permissions are actually needed for their project. Some other examples are the ability to disable service account creation. So for example, you may want to, within your organization, centralize service account creation and management to one particular service security team or to your SRE teams. And this allows you to kind of centralize that so that anybody acting within a project can't just create service accounts and give them roles. They have to kind of go through the security team in order to do that and get a service account with approved set of roles. So similarly, disabling service account key creation is another thing that you can do to help centralize this kind of management. Service account key upload is very similar. This is the ability to upload a service account, your own service account key, or your own key to a service account. And then another example that's policy constraint that's very useful is disabling cross-project service account usage. So this is the ability to use service accounts across projects. So one of the things that's typically overlooked within IAM policies is creating a service account in one project and then using that service account in a different project. This can be easily overlooked because when you look in a particular project's IAM policy, you may not see that service account used, but then it's actually used in a different project. And this can lead to confusion and to leaks where data from one project can be leaked into another project. So disabling this can sometimes be a help for security teams when they want to set up organization policy. Okay, so let's take a look at an example of how to set up organization policy. So first off, you need to select your organization within the Cloud Console. And within IAM, there's a Organization Policies tab or page. And this lists all of the different policy constraints that you can set within an organization. So we talked about the one disabling automatic IAM grants, and so we'll take a look at that. And right now, what we have is we have that policy, or that particular policy constraint is currently not being enforced. So we can kind of turn that on by clicking Manage Policy, and then adding an enforcement on that particular policy, right? So after doing that, this will actually go ahead and remove any roles that are on a service account, a default service account within a project that's affected by this policy, right? So we'll go to one of the projects that's within that organization. And we'll notice that when we look at that particular project's IAM policy, we don't see the default compute service account anymore because it doesn't have any roles associated with it. So when you look at the service accounts tab, you'll see that it exists, but it actually doesn't have any roles associated with it by default. So this is really helpful because it means that we're not giving these broad permissions to our services by default. Okay. So another area that I want to touch on or another product within GCP that I want to, or Google Cloud that I want to touch on is the Cloud Security Command Center. This is another way that you can, or another tool that you can use to know whether you're applying the principle of least privilege within your projects. Because what this does is this will scan your IAM policies and many other setup within your project and provide recommendations on what to do to further secure your project. So, for example, like one of the findings that we have here listed here is that a custom role is not monitored, right? So this is a low severity recommendation, but it's a good recommendation because when you create a custom role, you want to know like how that custom role is being used. And so what you can do is make sure that that custom role has audit logging set up so that you can audit when that particular custom role is being used within your organization or within your project. You know, others this will cover not just IAM, but other areas within your project, like networks, like whether your networks are monitored or like are doing audit logging. But in particular, things like the IAM recommendations are pretty important, I think. This will also pick up whether things like your IAM for things like buckets are monitored or not, so that it can help understand whether you're setting your IAM roles at the particular level, the appropriate level, like either at the project level or at the individual resource level, like the bucket level. Or, for example, if you're using Secret Manager or other projects or products that allow you to set IAM at that particular level, whether you're setting it at the appropriate level. So Cloud Security Command Center also will have things like AI-generated summaries that can help you understand the findings that come up. And it can also give you more steps on how to address those particular findings. So not just what the problem is, but also things like how to fix the problem that's come up. Another thing that's really interesting about Security Command Center is that the findings that come up also can generate messages on PubSub. So you can do different things like automating, doing some automation when there's a security finding. So for example, you might accept that PubSub message, and then that can call a cloud function, which can then gather other information in the project and enrich the finding by adding other metadata to the finding, or providing some sort of action within the project. So for example, if you have a new finding about a particular custom role not being monitored, and you want to make sure that those roles are being monitored, you could, in the extreme case, create a cloud function that accepts that and then goes ahead and either deletes or disables that custom role if it's not set up to be monitored, so that you're ensuring that you're monitoring all of your custom roles, for example. So this is really powerful for doing things like setting up automation and making sure that your projects are adhering to a base level of security. Another tool that's really useful within IAM to making sure that you're applying the principle of least privilege is the policy analyzer and the policy troubleshooter. So the policy analyzer is a way of querying your IAM policy to get answers about like which identities have access to do what within your project. Also to go the other direction and to say, okay, which identities have access to do a particular thing within my projects. So like, for example, who has access to read and write from the cloud storage buckets in this project? You can query the policy analyzer and get back which identities have access to do that. So this is really useful for understanding whether you have the right number of the right service accounts or have the right roles, and that you're not exposing too much within your project to possible exposure or exploitation. You can also do things like export results for this to perform further analysis. And there's lots of example templates for queries to perform real-world analysis. So it's a very useful tool within IAM. Another tool is the policy, like kind of a sister tool, is the policy troubleshooter. And what that does is it actually looks at logs to see whether that an identity has been using a particular permission or not. So what you can do is, if you want to make a change to a particular service account, you want to say, I don't think that this particular service account needs access to the cloud storage buckets. Let me delete that role. So what that allows you to do is delete the role, but test deleting that role, and then it will actually query the logs to see if that change to the IAM policy will actually affect the service account. Has that service account actually been using that permission or not? And if it hasn't, then, well, no harm, no foul. We can remove that service account or that role from the service account. But if it is using it, we can then further investigate maybe why it's using it. And in that case, you can make further decisions about whether that role is actually appropriate for the service account or not. So that's another, the policy troubleshooter is another good tool for doing this kind of analysis. Next, I want to talk a little bit about another tool that's really good for doing automation, the Cloud IAM API. And this is actually my favorite because I like to express a lot of things in code. But here what we can do is we can actually use the Cloud IAM API to query the Cloud IAM policies themselves directly. Or we can do things like using the policy insights within Google Cloud. So Google Cloud provides policy insights for IAM policies. So for example, if you have a particular role assigned to a service account, these policy insights get generated that say, oh, this particular service account is only using 5% or 5 out of 1,000 of the permissions that it's been assigned. That's a good indication that that service account has way more permissions than it needs. So we can actually query that using the API, and we can say, okay, like if a particular service account has many more permissions than it needs, maybe we should go ahead and just disable that service account and further investigate why that service account was created or who created it or things like that, or provide some sort of other automation that we can do. And so we can do that sort of thing in code using the Cloud IAM API as well. And these are easily deployed to things like Cloud Functions or within a project. So you can do very similar things to what you can do with PubSub and the Security Command Center. All right. So let's kind of wrap up and summarize what we've learned. So we've learned about custom service accounts and roles. So we know that we shouldn't be using default service accounts because they are really have a lot of way too many permissions for production environments. It's okay when you're kind of testing things out, but when you go to like actually creating things that are going to be used and are actually using data that's important and it is important not to be lost, we want to start creating custom service accounts and roles. And we want to create these roles with only the permissions that are actually needed for their particular use case. Next, we've learned that we can take these, we can set up these custom service accounts and roles, and then we can actually automate making sure that we are applying least privilege within our projects, and we're applying the right IAM policies within our projects. So we can automate access to either create service accounts or remove permissions or disable service accounts that have too many permissions, things like that. And we can make use of things like organization policies in order to make sure that we're not using default service accounts with too many permissions. And we can also use the IAM APIs in order to do different types of automation with actual code and either deploy those to Cloud Functions or some other, run those some other way. And then, similar to automation, we also want to monitor, make sure that we're monitoring our IAM policies to make sure that we're applying them properly as well. So things like setting up IAM like audit logging and monitoring, and using things like Cloud Security Command Center to scan and apply, fix the findings that come up within Cloud Security Command Center. And then use things like the Policy Intelligent Policy Analyzer and Policy Troubleshooter in order to check that we are actually applying the right level of IAM policy within our projects. Awesome. So I think that we're coming to the end here, but like one of the things that we want to highlight is that there's a bunch of special offers for attendees. So if you scan this particular QR code, these are, I think, various training offers and things like that for attendees. So if you're interested, definitely check that out. And your feedback is really appreciated. So if you found this particular talk interesting and you want to provide feedback, you can do that within the application, the next app. So please do that. That would help me and help others with their sessions and making those better for next year. So I want to thank you, and thanks for coming to such a kind of dry presentation on IAM. Thanks very much.